So guys, in this video, I'm going to introduce to you the basic three elements in an or in a DC electric circuit. So this video will be two parts. This is part one. So we're gonna, introduce here the resistance, the voltage source or the battery, and the current source. And in the next video, I'm gonna introduce you to you can say sub-elements because they are basically also voltage source and the current source, but with different properties. Basically, they are called dependent current source and dependent voltage source. That's in the next video. This video gonna have a resistance and the independent voltage source, which usually just called voltage source, and the independent current source, which again usually called just current source. Okay? So let's start by the resistance. The resistance is basically, the resistance to the charge. It tries to hinder the charge, of that basically makes the current. And basically, as the resistance increase, the current, of course, the resistance will, to the charge will increase, so the current should decrease. And the opposite, if the resistance decrease, the current should increase. Okay, that's, the physical meaning. Now, from circuit point of view, I need you to understand how the voltage and the current of a resistance, shaped, or basically their like signs or their direction. Okay. So basically, in any electric circuit, you can assume the voltage anywhere until it's given. If it's given that the voltage is somehow like from left to right or right to left or up, down, down, up, you have to stick to that. Otherwise, if it's not defined, you can assume it anywhere. So basically, you have like four combinations. Combination one here, combination 2, 3, and 4. So in combination 1, I assume the direction, opposite to each other. And also in combination 2. Okay? What mainly differs here in combination 1, the current is going from left to right. Okay? And the voltage is the opposite from right to left. In combination 2, they are also opposite, but the current is flowing from right to left, and the voltage again is opposite to that, from left to right. Okay? In these two cases, you have to find the current and the voltage with the same sign. They both positive or both negative. If you find otherwise, if they basically, if you assume they are opposite in direction, but you find that, for example, the current is positive and the voltage is negative, or vice versa, you have some problem in your calculation. So you have to bear this in mind. You have to bear this in mind. Okay. Okay. Now combination 3 and 4. Combination 3 and 4, as you see here, I assumed both in the same direction. Both are in the same direction. So, for example, in combination 3, the current is going from left to right, and also the direction of the voltage is also from left to right. Okay? In combination 4, again, they are in the same direction, but opposite to combination 3. So the current here is going from right to left, and also the voltage from right to left. Okay? And again, in these two cases, you have to find them with opposite sign. You have, if the voltage is positive, you have to find the current negative. I mean, the current must be negative. If you find out that the voltage is negative, the current must be positive, okay, or vice versa, okay? So again, if the current is negative, the voltage is positive in both 3 and 4. Again, in both 3 and 4, if you find the current is positive, the voltage must be negative. They must be opposite to each other in the sign. Okay, so either both have the same direction but opposite on sign, or both have opposite direction and the same sign. Okay, you can memorize it as this: same direction, different sign; different direction, same sign. Okay, I usually, and I want you also to do that. I assume either 1 or 2. because that's basically the physically correct. Okay, that's physically from, I mean, in nature, this is basically what it is. You know, I'm gonna explain it to you. So in nature, the current flows from the positive terminal to the negative terminal. So the current I flows from positive to negative. So where is the positive and negative here in combination one, for example? The positive is on the left and the negative is on the right. So the current will flow from the positive, which is on the left, to the negative. And the direction of the voltage is from negative to positive. That's why they are opposite. Okay? Same here in combination 2. As you see here, the current is going from right to left. Why? Because the positive of the voltage is on the right and the negative of the voltage is on the left. That's why the current is going like that. Okay, from right to left, from positive to negative. So I want you also to do that. Okay. Before we go to the next, like, basically element, which is the voltage source, as we're gonna see, just one note on the voltage. So the voltage direction is basically from negative to positive. So the head of the arrow is the positive, the tail of the arrow is the negative. Okay? And what it means, you know, the current, the resistance has like 5 volt, for example. That means that the positive terminal of the resistance has more voltage, has 5 volt basically, extra or more than the negative terminal. Okay? So that means, let's call this VR. That means that the voltage of the positive terminal has VR 5 volt, for example, 1 volt, 2 volt, whatever, plus V negative. That means here we can explain this, that V positive is higher than V negative with VR, with the value of the voltage of the resistance. Oh, so that VR is basically voltage difference. So VR here is basically voltage difference. Why? Just look at this equation here. VR equal to V positive minus V negative. That's V positive, that's V negative, that's V positive, that's V negative. You can continue, that's V positive, that's V negative, that's here V positive, that's here V negative. 2 terminals. So we call one of them V positive, we call the other one V negative. And basically V positive and V negative are just basically names. You can call them V1 and V2, whatever, you know, whatever you want to call them. Okay, that was the resistance. Now let's go to the second guy here, the voltage source. Wow, voltage source. So what is voltage source? Voltage source is your battery, basically, okay? The battery that you have at home gives you constant voltage, okay? And we are talking about here about DC circuits, okay? You can find it with many symbols. These 3 ones here are the most famous ones, okay? Whatever, they're just symbols, okay? But it comes in many shapes. So we deal with them in the same, like, there is no difference in analysis, you know, if it gives you like different shape or different symbol for it. Okay, we usually call it E, I believe, for energy, because it gives you energy. But again, you know, this is just a name. It can be called the V or whatever. You can call it Mustafa if you want. Okay. Now, again, in analysis, we need to know the voltage and the current direction of the battery. So the battery, the main function of the battery as a voltage source It gives you voltage difference. That's the main objective of a battery. It gives you voltage difference. What that means? If we call that guy, oh, by the way, so the long bar is for positive, so that's a positive, and the short bar is for negative, so that's a positive and that's a negative. Okay. Basically, that symbol here, which two symbols together, is basically it can be translated as like stacking multiple batteries together, in series like this one. Okay, that's why it's two batteries at the same time, but it's just one battery at the end. Okay, and again, here is very, very clear. Here this is the positive terminal and this is the negative terminal. So that's the positive terminal. That's the negative terminal. You can call this V positive. You can call this V negative. You can call this V positive. You can call this V negative. You can call this V positive. You can call this V negative. Or whatever name you want. V1 and V2, whatever you like. VA and VB. Okay. Now, we said that the main objective of a battery, it gives you voltage difference. It raise, V positive by E than V negative. So basically, V positive is equal to E, the extra voltage it takes, plus V negative. Or basically, you can say that E equal to V positive minus V negative. It gives you voltage difference. It makes V positive higher than V negative by E, by the amount of voltage given by the voltage source. Okay? How about the direction of the current and the voltage across a voltage source or a battery? They are the same. Okay? So I didn't give here like the four combinations, but I usually assume them in the same direction. And that's basically it. So if the battery is given like that, I assume the current like that. Okay? One note here, it's not like the resistance. So usually maybe 90% of the questions that you're gonna answer, you're gonna find them if you assume them like that. So of course the voltage of the battery has a direction like that from negative to positive. So as you see here, they are in the same direction. Okay, 90% of the time, if you assume like that, you're gonna find them both positive. 99, maybe 99%. But in some like fractional cases, you might find the current negative, although the voltage of the battery is positive. And that's because the battery can, discharge, it charges or give voltage, or it can be itself charging, like taking a charge from outside. Like just like for example, the rechargeable batteries in your home. If you take that battery, if it's charged, you can power using this battery something, right? You can put in a mic, for example. You can put it in a toy. You can put it in a mouse, for example, like this, and it will be the voltage source for that mouse. Once the battery is depleted, it has no more charge to discharge. You have to charge them, right? So you put the battery in the charger. In that case, the battery takes a current. So the current is going into, okay? So in that case here, the current will be positive and going into the battery. So in that case here, E is positive and the current is also positive. But this is very rare case. I'm not even gonna mention it. But you might find it in one of the problems or something. Okay? Especially if you have two batteries at the same time in the same circuit. You might have something like that. But normally, 99% of the cases, if you assume the current and the current of the battery is the same direction of the battery, like from negative to positive, you're gonna find the current positive just as the battery voltage. Good. Now, you might find two batteries in series in electric circuit. That's very fine. And that means we want to give more voltage or less voltage, according based on the case, to like the our load, so like a resistance, for example. Okay. So, for example, in this case here, let's assume this is called V1. And let's assume here that node is called V2. I'm gonna assume another node here called V3, and I'm gonna call this V4. Okay, where is the positive and the negative of E1? This is the negative of E1, and this is the positive of E1. Where is the positive and negative of E2? That's the negative of E2, and that's the positive of E2. So E1 is equal to V2 minus V1. The positive minus the negative. And E2 is equal to V4 minus V3. Again, the positive minus the negative. Okay? But remember, in between here, V2 and V3 as actually, this is actually a wire. This is a short circuit. That's a short circuit. That means it's just one node. So actually V2 is V3. Mathematically, V2 is equal to V3. Oh man. So we can remove, let's call it V, for example. So let's call V2 and V3 V. So I'm gonna call these guys here both V. So we can write E1 as V minus V1. We can write E2 as V4 minus V. So from here, from number 2 here, V is equal to V4 minus E2. So let's remove V here and put its value, V4 minus E2. So that means if we do that, so E1 equal to, I'm gonna remove V and put V4 minus E2. V4 minus E2 minus V1. Oh man. So V4, so E1 plus E2 equal to V4 minus V1, and put this in a big rectangle. Oh, so I can remove E1 and E2 and put, for example, E or whatever, put V1 here, put V4 here, and the E is actually E1 plus E2. Right? What's the battery doing? It raises its positive terminal than its negative terminal by amount of the battery, right? So here we can imagine E1 and E2 combined, they integrate into each other, forming another battery called E, and that E will raise V4 than V1 by E1 plus E2. And that's what I said in the beginning. I said that if you have two batteries like back to back into each other, meaning the positive of the first one is the negative of the negative is connected to the negative of the second one. That means you want to raise the voltage of the whole battery. You want to have a system with bigger battery, with bigger voltage. You find this like, for example, in your remote control, TV remote control, you're gonna find it takes like two batteries and they are opposite to each other. That means they are in series. Okay? Because the remote needs, for example, double that voltage. Good. So if we go to the second case here, so this is case 1. If we go to the second case 2 here, and we see here, oh, they are different from each other. They are opposite to each other. So where is the positive? So the positive of E1 is this one here, this node, and that's its negative. Where is the positive of E2? It's in here, and that's the negative. Oh man. So in that case, let's assume again this is V1, this is V4, and in this is V in between. You're gonna find in that case here that V4 minus V1 equal to uh, E1 minus E2. You can verify me, it might be the opposite, but I believe that's the case. Okay, so you can just go in the same analysis again, like just what I did, like what I did here, and you're gonna find the like the last equation. It's gonna be something like that. I believe it's E1 minus E2. You might find it E2 minus E1. Just let me in the comment of this video, but it should be E1 minus E2. And in that case here, what you have done is basically you reduced the voltage. You will not find this anywhere, by the way. That means like you connected them in the same like direction in the remote, so the remote will not work because it needs, for example, 2 volt. Each battery is 1 volt, but now it sees 0 because they are like canceling each other. Yeah, this is basically canceling each other. Okay, good. That's very good. Finally, what if you have two batteries parallel to each other? Oh man, you have to review our last video. You know, our last video, I talked about parallel and series. And I said if you have a parallel like combination of two resistances, for example, or any two elements in a circuit, they must have the same voltage. But look, my friend, let's call this V1 or V positive. This is called V negative. Why? Because E1 positive is here, E1 negative is here, E2 positive is here, E2 negative is here. So they have the same positive and same negative. So V positive here, let's have another color. V positive minus V negative equal to E1. And also be V positive minus V negative equal to E2. From the first branch here, V positive minus V negative is equal to E1. From the second branch here, V positive minus V negative is equal to E2. So if E1 doesn't equal to E2, that's a contradiction. So that's you will not find in basically in your analysis, in your problems that you're gonna solve. This is basically incorrect assumption. It violates our way of ideal analysis, basically. So you will not find that. If you find it, you have to find E1 and E2 have the same voltage. You must have if you find it, you're gonna find it in that case. So in here, E1 must be equal to E2. Must be. Otherwise, that's wrong. Okay? So, but why someone might do that? Because he want more current. So when we connect them in series, like this case here, back to back, we get more voltage. If you did this, E1 is equal to E2, that means you can double the current. But again, E1 must be equal to E2. And you will not find it. Don't worry. You will not find it. Finally, the current source. So what does the current source do? The current source basically provide its branch, the branch that is the current source is part of, with constant current. Just like the voltage source provides constant voltage, this guy is providing constant current. Okay, so it's a branch like this here will have I. So it provides constant current. In this case, equal to I or whatever, 5 amperes, 1 amperes, or whatever symbol you give it to it. What is the polarity of the voltage? Where is the direction of the voltage? Just like the voltage source. They have the same, like the voltage and the current have the same direction. So that's basically will be the direction of the voltage of the current source, and that's positive here, and that's negative here. Underground, like how this current source work, you're gonna find it, it's basically a battery, something like a battery. I mean, we don't have current sources in nature. We usually have the voltage source, and through some circuitry, that is connected to this voltage source. You will end up with some branch in the circuit with constant current. Whatever is a change happens in the circuit. Okay, so it's just like a battery, but in the battery, usually the voltage is known, but the current is unknown. Usually, here the current is known, and usually the voltage is unknown. And again, the voltage and the current, usually have the same, polarity. If the current, for example, is 1 amperes and flowing, for example, from left to right, and you assume that the voltage also from left to right, you're gonna find the voltage with some positive value, whatever it is. But it must be positive, just like what we talked about the battery. Now, what if you have two current sources in parallel? Oh, that's basically the analogous to the case in which you have two voltage sources in series. Okay? Basically, if you did that, that means you want more current. You want more current. So, for example, in this case here, both I1 and I2 in case 1, both I1 and I2 is going from bottom to up. Okay? So there are charges going, in two different branches from bottom to up. So we are expecting that the total charge here, or the total current here is basically I1 and I2. Okay? So we're gonna study in the future, a law called Kirchhoff current law or Kirchhoff current law, and we're gonna prove this for you. But anyways, it's basically common sense here. You have two sources of charges, I1 and I2. So we are expecting that, and both of them is pouring into the same branch, this branch. So we are expecting that this branch will have not double, but it's basically the addition of or the sum of these two charges that form the current. And the opposite happens if you have like two branches again, and I1 and I2, but they move the charges in opposite way. So I1 here going from bottom to up, I2 is going from, or the charges of I2 going from top to bottom or down. So basically, we're expecting here that I is equal to I1 minus I2. Or I2 minus I1. You can assume it in any way you want. Now, what if you have like two current sources in series? Oh, that's analogous again to that case here. Two batteries in parallel. Okay. So again, that might be valid in just one case. If and only if I1 is equal to I2. So that is valid only, or if and only if, we can say, if and only if I1 equal to I2. The most common case basically is this one here. I mean physically in nature. If you want more current, you add another current source in parallel. You usually don't do that because they are canceling each other. You usually don't do that. Because if you want double to increase the voltage, use two voltage sources. Okay. So the current here, I must be I1, and I1 must be equal to I2. Otherwise, this is invalid, incorrect. You will not find it in nature, or no one will do it. Okay? It has no purpose. Okay, guys, that's basically, this basic introduction. And see you in the next video. Bye-bye.